Our group represent our analysis salary disparities, a study on gender difference and professional experience based on demographic, gender, and year of experience. In this project, we use statistical tools to analyze data and understand how companies make salary decisions. Fair pay is very important in any workplace. Even though companies try to pay everyone fairly, salary difference still happen. Our study used data from 150 working professionals to see how background factors affect monthly salary. We are looking at two main problems. First, the gender wage gap. We want to check if male and female are truly paid equally in the modern workplace. Second, does more experience always equal a higher salary? Usually, people think senior workers must earn more. We want to test if this idea is statistically true. To answer this question, we have three objectives. First objective, to look at the basic profile of our respondents, including their gender, education, and year of experience. For objective 2, to compare the average monthly salary between male and female to see if there is a real difference. For the objective 3, to check the relationship between year of experience and monthly salary. This study is important because it helps HR department fix unfair pay system, help manager support equality, and show how real world salary are calculated today. I will now hand over to Umi to explain our methodology.
Thank you, Fatin. I will explain the methodology used in this study. This study used a secondary dataset obtained from the Kaggle platform. The dataset contained information on professional employees and their salary profile. A total of 150 observations were selected from analysis. The variables used in this study are gender, education level, year of experience, and the monthly salary. Gender and education level are categorical variables, while the year of experience and the monthly salary are numerical variables. To achieve objective 1, descriptive statistics such as frequency distribution, percentage, mean, and standard deviation were used. Graphical presentation, including pie chart, bar chart, and histogram, were also used to summarize the data. For objective 2, an independent sample test was conducted to compare the average salary between the male and female employees. For objective 3, tuition correlation analysis and the scatter diagram were used to evaluate the relationship between the year of experience and the monthly salary. IBM SPSS statistic was used as the main software for this study because it is available and widely used for data analysis. SPSS helps us organize the dataset and generate descriptive statistics such as frequency, percentage, mean, and the standard deviation. It was also used to create the graph like a pie chart, bar chart, and histogram to present the data clearly. In addition, SPSS was used to perform inferential analysis, including the independent sample t-test, Persian correlation, and the scatter diagram to answer our research objective. Let's look at our first descriptive objective. Starting with the gender, the SPSS output shows that out of the 150,000 professionals, 81 are male, or 54.0%, and 69 are female, or 46.0%. We use a pie chart to show this data. Since the gender only has two groups here, a pie chart is the easiest way to show the split. This indicates that the sample is relatively balanced between the male and female respondents, allowing a fair comparison of salary between the two groups in the latter analysis. Next, we look at education level. This data shows the three different groups. which is the bachelor degree holder, formed the large group with the 82 respondents or 54.7% of the sample. This is followed by the master degree holder with the 51 respondents or 34.0%. The smallest group consists of the PhD holders with the only 17 respondents or 11.3%. A bar chart is appropriate because it allows us to compare the frequency of different education categories clearly and effectively. This finding indicates that the most respondents possess at least a bachelor degree, suggesting that the dataset mainly represents a highly educated professional workforce. I will now hand over to AMIRA to present the descriptive analysis for the numerical variable, namely year of experience and a monthly salary.
Thank you, Umi. I will present our continuous numerical variables starting with years of work experience. Our SPSS analysis shows that the average or mean experience is 10.25 years and the median is 9.5 years. This means half of the workers have less than 9.5 years of experience and half have more. The data is multimodal and 2 years is the most common lowest mode. The standard deviation is 7.02 years, which means there is a wide spread of experience levels. The lowest experience is 0 years and the highest is 25 years. The skewness value is 0.374, showing a slight positive skew. This means we have slightly more workers who are in the early to mid stage of their careers. We use a histogram to show this data. As you can see, the highest bars are between 2 and 3 years. A histogram is ideal for this because it groups numbers into ranges, showing us the overall spread of work experience. Descriptive analysis, monthly salary. Now for monthly salary, our SPSS results show a high average mean salary of RM95,753 and 33 cents and a median of 19,000. The lowest most common mode value is 40,000. The range is very large at 174,000, stretching from a minimum of 30,000 to a maximum of 204,000. The standard deviation is also very high at 47,828 and 82 cents, which prove that there is a big salary gap among these professionals. The skewness is 0.612, meaning the distribution is right skew. The mean is higher than the median because a few top earners are pulling the average up. Our histogram for salary shows this clearly with the highest peak at 40,000. A histogram helps us easily see where the salary groups cluster. I will now hand over to ALIAA for the inferential statistic.
Thank you, Mira. Now we will look at Objective 2 to compare the average salary based on gender. We use an independent sample t-test to compare the average salary of two different groups, which is male and female. From our SPSS data, male workers have an average salary of RM103,370.37, while female workers have an average salary of $6,811.59. For the hypothesis, null hypothesis HO show there is no significant difference in average salary between male and female professionals. Meanwhile, alternative hypothesis H1 show that there is a significant difference in average salary between male and female professionals. In the hypothesis testing using p-value, we compare the value of p-value is 0.034 with value of A is 0.05. Because of p-value is less than alpha value, we reject the HO and accept the H1. Thus, there is a significant difference. So, the decision, there is a significant difference in the average salary between male and female workers. On average, male employees earn more than female employees. Lastly, the independent sample t-test is appropriate because the goal is to compare the mean salary, a continuous variable between two independent male and female. Lastly, the objective 3 is to evaluate the relationship between years of experience and monthly salary using Pearson correlation analysis. The SPSS results show a Pearson correlation R of 0.893, p-value is 0.00 and alpha value is 0.05. Since the p-value is less than a value is 0.05, this means there is a significant relationship exists between year of experience and salary value. However, the R value of 0.893 show a very strong relationship. This meaning that as year of experience increase, salary also tends to increase. Next, the scatter plot show a clear upward trend indicating a positive linear relationship between years of experience and salary level. As employee gains more years of experience, their salary generally increase. The points are closely clustered around the upward trend, supporting the strong positive correlation found in the Pearson correlation analysis. For objective 3, we are used Pearson correlation analysis because both years of experience and salary level are continuous variable, and this study aims to determine the strength and direction of their relationship. Pearson correlation is appropriate for assessing linear relationship between two continuous variables. The analysis shows a statistically significant strong positive correlation between years of experience and salary level, indicating that employees with more years of experience tend to receive higher salary.
Thank you, ALIAA. In conclusion, our team have achieved all three goals. First objective is demographic. Our sample of 150 people has a good gender balance, mostly bachelor degree holder and very wide range of the salary. Second, objective 2, gender pay. The t-test proved that the salary difference between male and female is not significant. P equal to 0.034. Pay equity is good. Third is objective 3, experience link. We found a strong negative relationship. R equal to negative 0.893, P not more than 0.001. Based on our finding, we suggest the following steps. For company, first, fit unfair salary structure. HR should review salaries. The negative relationship show that senior worker might be facing stuck wage or new hires are being brought in at very high salary rate. Second, use skill-based pay. Since year of experience do not guarantee higher pay in this data, company should reward actual skill and performance instead of just counting year of service. For future research, first look at industry type. Future study should look at the type of industry like tech or finance. The younger worker in this dataset might be earning more because they were in high-paying tech field. Second, use random sampling. Since we use a convenient sample from Kaggle, we cannot apply this to the world population. Future projects should use random sampling for better accuracy. Overall, this project helped us learn how to use digital software like SPSS to turn raw number into a smart business recommendation. That's all for our group. Thank you.